Today our discussion is going to be on exponential decay. So one of the nice things about exponential equations is we have the same equation if it's a exponential growth or decay, either one. But what's different about this is that b will be in between 0 and 1. So in other words, it'll be a fraction or a decimal. So remember from yesterday that a is the amount that we start with, and b will be what we call the decay factor, and it will be a fraction instead of a whole number. So we'll take a look at our first graphing problem and see some similarities and differences from growth. So all of our exponential decays will decline. This is called a decreasing function. So as x gets larger, y will get smaller. The domain are how far right and left does this graph go. This is all reals. The range is how high and how low we go. This is still y will be greater than 0. So we'll have an asymptote where the graph gets closer and closer to but never touch. And the first example that I want to show you is, so when you punch this in your calculator, go to your y equals, and when we graph this, we can see that it is a decline. And to get some points, hit second table, and this will give you some points that you can graph. So get some positive and some negative points. You can see at 0 we have a 2. At 1 we have 1.5. 2 we're going down and down. And at -1 we go 2 and a little bit more. So you can level yourself off to get your asymptote, and that's how we graph our decay problems. In the next example, you'll see how the decay problems can be shifted to the right and left, and maybe up and down. So again, most exponential equations will still have this format: a, b to the x. A is what we would start with. B is our decay factor, you can see. This is going to be shifted to the left and up. So if you go to your calculator and punch that in, again you'll see kind of a decay. It levels off at 3. This is your asymptote, and it kind of comes in, and as x gets larger, y gets smaller.